See, a pathway is projected from a point O.
Yeah, so basically a particle is projected from a point O. Suppose this is our point O, yes? And this is what happens when you project a particle upwards. This is what happens. Maybe we are projecting this particle with a speed what?
Of 31.5.
With a speed 31.5 meters per second. This is from point P, from point O. Yes.
At an angle of 30 degrees to the horizon.
At an angle of 30 degrees to the horizontal.
And at the same instant.
At the same instant, at the same time. Yes.
A second particle Q is projected in the opposite direction.
As a second particle Q now, eh? So this was P?
Yeah.
Yeah, this was particle P, and now another particle is projected in such a way that these particles collide. Yes? At what velocity?
Velocity of 21 meters per second.
21 meters per second. At what angle? We don't know. Maybe at an angle that we can call theta.
Then from point O.
Yes.
I see from a point level with O and 100 meters from O.
Oh, so from a point level, so we shall have 100 meters here.
So from there, there's 100 meters.
Yeah. So it means when the collision occurs, yes? Of course, when the collision occurs, these particles will have moved, yes, in the same time. Maybe we can call this point what? Point 1. We shall take an assumption that this particle P has moved distance x1. Yes? Then this particle Q has moved distance x what? X2. Right? But we know that x1 plus x2, this should get us our 100. That makes sense?
Yeah, it does.
And again, they want the angle of projection. Yes? Now, at the point when these particles collide, they will be at the same distance from the ground level. Does that make sense also? Now, if it does make sense, if I consider my particle P, if I consider my particle P, of course, I have the angle of projection, I have the initial speed, and I don't have the distance. So basically, I must use the second equation of motion. But this is projection upwards. We are in opposite gravity. So G must be negative. So I'm going to say, maybe let me call this S1 or SP, whatever you may call it, is equal to, now this must be UT minus a half GT squared. But our U, now we must look for the vertical, because we are considering vertical motion. We are going to look for the vertical component of the initial velocity, and this is going to be 31.5. Of course, sine what? Sine 30 degrees. Then times t altogether, then minus a half gt squared. Can I call this equation 2 now, because we already have equation 1r. Yes? Then I'm also going to consider particle Q. Now for the case of particle Q, let me call this S2. This is UT minus a half GT squared. You will ask teacher, why are you not changing the T? That this becomes T1 and this becomes T2. No. At the point of collision, that's what I'm considering. Yes? At the point of collision, they will have these two bodies will have moved in the same time.
Because they're all projected at the same time.
Instant.
Instant
means at the same time. At the same instant. At the same time. You get it? So my S2 is going to be, of course here, I'm also going to look for the vertical component of the initial velocity. This will be 21 sine theta. I'm simply substituting here. Then times t minus a half gt squared. Yes? Me and you are going to agree that at the point of collision, yes, S1 is equal to S2.
Distance covered by the other one is equal to distance covered by the other one.
At the point of collision.
Okay.
Not distance covered by. The distance at the point of collision. You see, this is a body and this is another body. They have collided. That's the point of collision. The two bodies will be at the same distance from the ground.
Oh.
You understand? Because we are simply considering the vertical distance. Altogether, that is why basically this will have moved vertically SC1, and this will have moved vertically S2. So at this point of collision, yes, the distance this is from the ground must be equal with what the other one is at. Yes? So permit me say that 31.5 sin 30 is a half, sin 30 t minus a half gt squared must be equal to 21 sin theta, of course t minus a half gt squared. Why am I bracketing this? Yes? If I don't bracket, it becomes sin 30t, meaning t will now become part of 30, which isn't the case. That's why I put in what? In brackets. Mathematically, this guy and this guy go for a pattern. Yes? Then we shall remain with 31.5 sin 30. Sin 30 is what? Sin 30
It's 0.5.
of course t, yes, sin 30 is a half indeed. This is 21 sin theta. Sin theta what? Sin theta t. Now you can see the t's have gone for a pattern. Then I will remain with 21 sin theta. This will be equivalent to 31.5. Then sin 30 degrees. Permit me make sin theta the subject of the what? Of the formula. This will be 31.5 sin 30. Then I divide by 21.
Which is 0.75.
And then again?
Sin theta.
So you can get theta as the arc sine. Get theta as the arc sine of the whole thing. It's good to get the whole thing.
It's 48.59.
So theta is 48.59 degrees. Therefore, the angle of projection of a particle Q is 48.59. For the case of space, you people first write that.